spacing out some of these things going into chapter 12. Since we have the time, we're just going to kind of take our time. Because there's no absolute rush to get through a lot of it. When with people out, AP tests and stuff like that, today isn't a bad day just to kind of briefly start a little bit of 12.1, and then we can get into the rest of it tomorrow when everybody's back and go from there. So we get this idea of what's called the fundamental counting principles and permutations. We're going to get through a whole bunch of different things with probability statistics and all that kind of stuff. The way we start with this stuff, though, really is just how you do arrangements, how you do counting, how many possible outcomes could there be before we get into probability itself. With any luck, we'll probably do some probability. I'm guessing, I think it's Thursday or Fridays when we start really getting into it. So I think Friday might just be playing cards. It might be our cards day. So and it's a lot of how do you think things through and how you go through stuff. So we'll get to it. So basically, what we're looking at is how many different sandwiches can you make from the following? If it is, and you guys do a lot of that with the possible outcome. What's that? Yeah. Yep. So if you've got 4 types of meats, 3 types of breads, and 2 types of cheeses, how many different sandwiches can you make if you had to choose one from each category? Well, a lot. Yes, a lot. There's a lot there. The idea is that you could do one of 2 things. You can start by making a sort of a chart. You know, whether you're taking ham on white with Gouda. There's a button for what? There is? Stat, right? No, there's a couple of different buttons on the calculator that you will be using, but I don't think we'll get to that quite yet because there's a difference. So there's a button on here that says stat. I thought there was.
There is. It's right under delete. We don't know. Next to the arrows and all that.
Oh, there it is. Sorry. So there's this one where you have your edit, sorts, calculate. We're going to use some of this. Actually, none of those really. Z-test, I don't think we'll do any of those. So yeah, you said alpha window, alpha zoom. Yeah, this is your permutation, combination, and factorial. So permutation and combination are things that we will be talking about here, probably more so tomorrow. Maybe just talk a little bit about one of them today. I think we'll talk about permutations today, and then go from there. What's that? Probably. You need to charge it? Yeah. I'll just bring the charger. Here. Probably just needs a minute or 2 to juice it. Anyway, back to our sandwiches. In case you weren't hungry now. One of the things I said you can do is you can make some sort of a chart if you want and try to list everything through. But another way is that how many different types of meat do you have to choose from? How many types of bread are there? And how many types of cheese? What's 4 times 3 times 2? 24. There's 24 different types of sandwiches you can make if you go through like that way. You're picking one from each. You have 4, 3, 2. And you get 24. Okay? Now, that doesn't seem so bad when you start talking about just that many, but if you think about Subway. Now, when you go into Subway and you really start thinking about all the different types of meats and stuff that they have, we actually counted this out. I think last year we went on their website and looked at how many different types of meats they had, different types of bread, different toppings, spices, like mayonnaise, oil, vinegar, salt, pepper, all that kind of stuff. And then the last one is the 2 was toasted or non-toasted. So What's that? Well, now if you go through it, put in your calculator, what's 13 times 6 times 24 times 12 times 2? Now this is obviously if you're just picking one of each. Then you can start getting into, I could pick multiples if you wanted to, but the idea is if you pick one of each, what are you getting? 44,000 what?
44,920.
So if you think about it, if you've got 44,928 and you wanted to have one Subway sandwich a day, so 44, oops.
That's like the rest of your life is a Subway sandwich. But you should divide it by 30.
So basically you can have one Subway sandwich a day for 123 years.
Get on there.
Oh, sorry.
Yeah, it's
So, and if you think about it, what's the average life expectancy nowadays? About 80 years, we say about 80 years, somewhere around there.
if you have one for each meal every year, it would be 41.
41 years, 3 meals a day.
Yeah.
So think about any of you guys have had younger siblings or you have nieces, nephews, or cousins, stuff like that?
Yeah.
Little children start to eat solid foods at 1-ish, but they're probably not going to eat a full Subway sandwich until they're about, we'll say maybe about 6. So if you go from about age, let's say, make it easy, age 5. Age 5 to expected life, 80, so about 75 years. So if you take your 44,928, so you'd have to have basically 600 sandwiches a year. 600 sandwiches? Now, think about it. 600 sandwiches. That's 2 a day, all right? So you're looking at 2 a day. Nowadays, sub sandwiches aren't cheap, are they? They're like, if I'm looking at, let's just a sandwich, they're what? $7? I know, right? All right, are we doing 6-inch only here or what? Let's say they're 6-inch. Right? So 6-inch sandwich now is what? $4? $5? All right, so let's say $4. So you're paying $2,400 a year at Subway. I know it's a toss up here, but you start getting into the idea of how much there really is. It's a lot. Don't know if you want to don't know if you really want to go for the Jared jokes.
No, probably not.
We can go for the milk coffee.
No.
Oh boy, they turned on them quickly. Anywho, like I said, we can make a diagram, and I had a funny diagram for you.
How is it?
Because there's a turkey. There's turkey on white.
Extremely comical. Yes, so these are fun.
No.
This is what I get for
That's what
trying
you
to
were
be
thinking
funny.
about.
Same idea with, don't write all this out. This is basically when you start thinking about ways, how many different ways outcomes can occur. This fundamental counting principle, if one event can occur in so many different ways and another event can occur in so many other ways, the ways that both events can occur is when you just multiply them together. If you think of it this way, when you're talking about, when we looked at sandwiches, you've got all those different meats you can choose from, different breads you can choose from. You can differentiate between 6 foot and foot long as well, because you have to make choices for each one. I'm sorry, 6-inch and 1 foot sandwiches. So yeah, if you had to eat 600 6-foot sandwiches over the course of a year, that's the other thing. I hate the way Subway smells. That, when it's gross. It's like every time I just avoid Subways because I just don't like the funk, Subway funk. You know what I'm talking about? The Subway has its own funk, and I just don't like the funk. I haven't had a Subway sandwich in probably about 3 or 4 years. I just don't go there. I don't know. Anyway, so one of the things you can do, and I tried to figure this out once, was I was looking at, I forget who it was in class. I was counting one time, like jeans, if you had pants and shirts. We had one kid, it's like, okay, I forget who it was a couple years ago. Like, all right, so if I have 19 pairs of pants and 37 t-shirts, how many outfits can you make? Well, if you just multiply them together, you get a lot of different non-repeating things. Now, I started thinking about, okay, shirts and ties, and what I have. I have shirts, ties, dress slacks, and things like that. You start getting into it, and if I'm not mistaken, I counted, I think I have 11 pants, and then, how many shirts do I have? I totally forgot to write this down. I looked at it this morning too. I want to say I've got like 22 shirts, but I've got like 40 ties. I got a bunch of ties, and most of them I don't even wear them. I don't know. I've got a couple. I don't have any novelty ties. No, I don't have. I'm not a novelty guy wearer. Yeah, I remember that. And then you start getting into polo shirts, and then jeans. Not Jens. No, because these like dress pants, like khakis and things like that. Dress pants. Oh, geez, you get into socks. Socks. Yeah, all right. So socks. I'm a big fan of cool socks. I like obnoxiously cool socks, and Happy Socks is a brand that makes really nice dress socks. They're covered. Anyway, I probably have about 24 at least pairs of those. Golf shirts, polo shirts. There's probably 15. Probably have like 4 pairs of jeans or something like that. So if you start going through just your own personal wardrobe and you start thinking about how many different outfits could you come up with that throughout the course of a year. What is it? Super silly big number? So, I have to read it out loud. If I did if they counted this out correctly, I have 1393920. So basically, there's 13 million different combinations of stuff if I choose. That means I'm choosing one of each to wear. So I'm going to wear a polo shirt underneath my dress shirt while wearing jeans and slacks at the same time. Obviously, you're not going to do all that, but you start looking at the different possibilities that you have. It just becomes stupid. So for those of you guys that happen to have many pairs of shoes or many pairs of shorts or t-shirts, as you go through and you really start to figure out how much stuff you really, really have, is when you try to figure out how many different combinations you can come up with. Then it just becomes stupid. Like really, really big numbers. I thought it was kind of cool. This was another one. They do this one pretty regularly as a very simple example. Let's say the masked bandit stole somebody's pencil case, and we didn't know who the masked bandit was, but we had the sketch artist was able to come up with. Well, we happen to have 195 different hairlines, 99 different eyes, because somebody might only have one. It's a joke, because I guess it's sets of eyes. Eyes and eyebrows, because things. 89 different noses, 105 different mouths, 74 chins and cheeks. So The sketch artist is going to be able to distinguish between that person that may or may not have stolen something on somebody, because you never know what happens. And if you start multiplying that out, how many different ones did you get?
Oh my God.
Big numbers, stupid big numbers. So this is 1.33 times 10 to the 10th. Now, if I remember my scientific notation correctly, then it's what? 1, 2, 3, 4, 5, 6, 7, 8. So that's 13 billion. That's a small number, yeah. You know, there's only a couple people. 13 billion. Isn't that like?
Yeah.
Yeah, it's gonna say it's more people than there's on Earth, right? So that's. Yeah, so it's a good thing that somebody was able to spot the masked bandit, that maybe they were able to figure out that here's all your bad guys. But what happens if the masked bandit, all you could have seen was their eye and their nose? And you were able to figure out their eyes and their nose, so you no longer have to worry about, you know what the eyes are and you know what the nose is, so that changes from 99 to 1. 89 to 1. So it was eyes and eyebrows. They come together. They're a package deal, yes. So you're just at 195. So what do you get now? Much smaller number? Oh, but because you knew the eyes and nose, so we have to multiply everything else out. So what do we get now?
15, 0.
So you've got a better chance now. You've got a 1 in a million chance. Anyway, so the idea is, if you're getting robbed or you're getting stuff stolen from you, look at them. Find those distinguishing marks. Then you need to set up security.
Where you look for one thing with the highest probability of finding a smaller percentage of people with that thing.
Correct. So that's why they always say, like, self-defense classes and things like that. I'm sure you might have heard this. You always try to be aware of your surroundings. You know, it sounds silly, but the idea is that if you're able to have, I mean, God forbid you guys, and you literally really get robbed, you're going to be able to help distinguish what somebody looks like. So that's what I'm getting at. So don't beat people up and steal their things, because they're going to figure out who you are. Well, now, if you wear a mask, that's a good idea, because it's hard to tell who you are. A Sharpie marker mask? Not very bright.
No.
Unless it were unless we're using like a bright Sharpie. What? I don't know.
Extra credit for wearing a mask.
Yeah, you guys should all wear masks tomorrow, and we'll all figure out. So let's see if we can figure out who is who in the lineup. Who is Kaiser Soze? I know, right? Yeah, all of a sudden you guys all get up and switch seats. I go, who are you? I don't know who you are. Same things go with license plates. As you get going into license plates, you get to choose. Well, most of you guys are getting to be of the age where you start looking at cars and things and all that. As you eventually get there, license plates, the way that license plates are done is that if you don't go with vanity or personal plates, you just get random selections. Okay? Now, in the state of New York, they do 3 letters, 3 digits, 3 letters. I know. I'll show you Illinois here next. And as you go through that, how many different license plates of digits and letters can, if you can say that numbers can be repeated? That's an important thing here. If numbers can be repeated, how many digits are, let me rephrase that. How many digits are there if you're looking at numbers? 10 digits, 0 through 9, right? So that means if my first one, I'd have 10 to choose from. The next one I'd have 10 to choose from. And the next one I'd have 10 to choose from. That's if I can allow for repetition. Are we okay with that? If I did not allow for repetition, I'd have 10, then 9, then 8. Really simple. Same thing with letters. How many letters are there? 26. So if I don't go with, if I allow repetition, that gives me that many different possible license plates, just by multiplying all that out. It's another big number, isn't it?
Yes.
Okay. Now, if you do that without repetition, it cuts out. And now this is just talking standardized stuff, okay? This is just basics. So if you did repetition, if you allowed for repetition, let's see here, we had 10 to the... So here's your allowing repetition. You basically have, what was that, 17.5 million different license plate combinations. Okay. If you don't allow for it, oh. And then obviously it's substantially, it cuts it down. Now Illinois is different. Illinois, if I'm not mistaken, you get seven numbers, letters. Now, depending upon whether it's a car plate or a truck plate, a standard car plate goes letters first and then numbers, and I think a regular one, or it's, yeah, letters and numbers. Now, you can mix it. I think they've started doing like C, and then there's just a whole bunch of numbers after it. They're doing a lot. They've changed up a lot. Yeah, and then if you start getting into personalized plates, then you're allowing yourself to pick plates and things like that. Now, what's really kind of cool about Illinois is that, I don't know if you've ever looked at the Secretary of State's website. So, yeah. As you start to get older and you have, cars, and you might want different license plates, because I'm a nerd, I put fancy license plates on my car. Yeah. So our cars have fancy plates. My motorcycle has fancy plates, just because. No, my motorcycle is really cool. It's gone. I gone. I thought it was really cool license plate.
So edgy.
You get it. Gone. Yeah. And it's a Cubs plate, But both my wife's car and my car, we both have Murph on it, and then Murph 1, Murph 2 is what we did. If we get another car at some point in time, hopefully Murph 3 will still be available. But what's cool is that, yeah. So that's the thing on the Illinois, on the Secretary of State's website. You ever got so fancy that you wanted to start to look for things as you got older? As we get going into Powerball stuff, when you start, you go back into the idea of possible numbers. Now, you guys all know what Powerball is, right? Yeah. That's like the lotto and all that. It starts with 54. That ping pong ball doesn't get replaced. So you have 53, 52, 51, 50, and so on. Now, as you start multiplying all this stuff together, your calculator is going to say, it's a lot of numbers. So if you multiply all that out, you've got the first 5 numbers, and then it goes to the Powerball, which means there's another 54 to choose from. Actually, I think they've changed this now, and there's more numbers. Bless you. I want to say it might have gone up to like 60. I think they've gone to 60 on those. I could be wrong, but I know that the numbers have changed. So if I multiply all that out, not quite yet. So 2.049. So that gives us.
Oh, that's a big difference.
So we'll move this over. What I need to add, it was 10. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is that? 2 billion? Oh yeah, 20 billion. That's even better. So basically there are 20 billion different setups of numbers that you can do. Yeah, 20 billion. So when you see somebody, when the Powerball is at, $100 million, whoa. $100 million is just a fraction of 20 billion. Even if you spent $1 billion on the lottery, it doesn't mean that you are going to have enough money to cover all the possible combinations. So you could spend $1 billion and still not win the Powerball. You still have the idea, but the idea is that the probability is so improbable. I mean, we're talking, in order to win, it's 1 in 20 billion, okay? You have a better chance of being mauled by a tiger living in DeKalb to win the lottery. You have a better chance of being struck by lightning 3 times in your lifetime than winning that. There's the idea that as you start getting into large numbers, it's so astronomically crazy that any of that stuff actually happens. So when you see Powerball getting up there, it doesn't matter if it was 100 billion or 100 million, 400 million, 800 million when it was a couple of years ago, or $50 million. The idea of actually winning it is so unbelievably improbable. It's crazy. So big numbers, big crazies. What's that? It rolls over. So let's say it starts at $20 million. If nobody wins it that week, it rolls over to $40 million or $35 million, depending upon how many people buy tickets, and then just continually grows. Okay. They grow at a faster rate the larger it is, because more people think they're going to win, so they buy more tickets. More people will pay. More people will play Powerball when it's $400 million than they will when it's 40, because that extra zero is going to make all the difference in the world.
Oh yeah.
Generational wealth doesn't just happen at $40 million. It's got to be $400 million. So, but yeah, it's crazy. Yeah. So a small story. A kid that I went to junior high with, his parents won the lotto when we were in like 6th grade. The family won like $4 million. Anyway, so there was that story. I don't know if we're gonna get to arrangements today. No, yeah, let's stop. We're not going to do arrangements today. We'll worry about this stuff because this starts to get into what we call permutation combination. We'll worry about that tomorrow. So today, hello.
Today's Purple Day.
Hey,
That's all I got.
hey, we're doing probabilities, sir. And we did like
Probability that I will interrupt your class.
no, we did the
Three can't be a problem.
how many shirts and pants and things do you have?
Oh, well, if you haven't noticed, I wear the same 3 pants in rotation, the same 2 shoes in rotation, and I only have like 6 or 7.
So 3 times 2.
Oh, I have tons of socks. I don't recycle socks.
How many shirts?
Like 7 shirts
And
that I
then
actually wear.
we'll say a dozen socks.
I've got a dozen different hair ties too, so.
Oh, okay.
How many different combinations can I make?
Wait.
2048.
But now, hold on. I would never wear brown shoes with brown pants or black shoes with black pants. So some of those combinations are no good.
I agree. This is just pure counting.
Ah. You guys wonder.
Priority is fine. Is the 12.1 already posted? There's 4. I think everything. Oops. All right, so we'll stop here. So let's see, page 705. Oh, sorry. Yeah. Do those. Should be pretty easy. Yes, sir. I did? Oh, okay. I thought I did.
International what day? Is International